Hello everybody, this is Andy Pils. It's day 23 of our astronomy unit, and in today's lesson we talked about the formation of stars and the solar systems that form around them. So in this video I'll go over a couple of the activities and some of the questions related to the content from today. So first off, we do have this link to the website for the Interactive Solar System Simulator, which is kind of similar to that open space program that I've used in a couple of the videos, but just to kind of give you some controls too, you can zoom in and out if you have a scroll pad, and also if you use kind of like the video game controls, the WASD. W will zoom in, S will zoom out from whatever celestial object you're focused on. A and D will rotate the camera around, and you can also kind of click and pull the solar system in the direction that you want to move it to. And also, where the other one? C and Z will pan the camera, I don't know what direction this would be, horizontally, in order to give yourself a better view of what you're looking at. So you can move around pretty much our galaxy. Once you zoom out, you'll really zoom out on our solar system, zoom out for a while. Once you start doing that, the stars in the background will finally appear to move just because we're zooming out so quickly. And then once we get to the end, we're going to see our Milky Way galaxy, which, as you know, is just a small portion of our universe as a whole. But this website has a lot of good information that will help you not only just fill out this table, but learn about the different celestial objects that we have here in the Milky Way. But other things in this lesson, moving forward, so make sure that you watch the videos. They'll be able to show and explain the nebular hypothesis, which we've already spoken about a couple weeks ago, but this will be a good review. Talk about the formation of the sun and the planets, and then we'll move into these Regents review questions. So these are from the lesson, and I added a couple more based on similar content. So it says the diagram below, which shows an inferred sequence in which our solar system formed from a giant interstellar cloud of gas and debris. So we know that these interstellar clouds of gas and dust are nebula. So you should already be thinking that this is talking about the nebular hypothesis. Stage A shows the collapse of the gas cloud. Stage B shows its flattening. And stage C shows the sequence that led to the formation of planets. So from stage B to C, the young sun was created when? So what happened between this stage and this stage here is we have gravity causing things to be attracted to one another, and therefore it's going to contract. So that's going to have everything forced together. That's going to create that warm, dense center of the disk, which once gravity really increases to the point where atoms can actually smash together, fusion will occur, and then we have a sun, which is what happens here at stage C, which is labeled. So it says after the young sun formed, the disk of gas and dust, well, what happened to it? So here we see it talking about the disk forming with a central bulge. Here there's the disk of gas and dust again, spinning around the young sun. And here the dust will clump into planetesimals. So the best answer here would have been they eventually formed into planets. Sorry about the misformatting over there. But all of the gas and dust, that's going to clump together. And then because of gravity, the same force that is forming our solar system, the planets are going to form, and they're going to be layered according to their densities. So with the most dense materials on the inside of the planetesimal and then the planet, and then the least dense materials like your liquids and your gases towards the top or the surface of the planets. Let's look at a couple more related questions. So here's one from June 2017. Which process produces the largest amount of energy given off by stars? Well, that would be nuclear fusion, better of these options. and it's fusing. Which one would it be? Would it be lighter into heavier or heavier into lighting? Well, remember, it's gravity forcing these things together, and that's what actually generates the electromagnetic energy that stars produce. So the correct answer here would have been lighter elements into heavier elements. What else do we have? So another Regents question. Here's just a simple algorithm of what's happening from step to step. So a lot of times it'll be presenting the same information and asking about the same information, just with maybe different diagrams, but it's usually looking for gravity. It's the attractive force that causes everything to form and come together. And it's usually talking about the process of fusion. So you're going to keep seeing force of gravity, process of fusion, keep coming up in these questions related to stars. And here's another one. Identify the force responsible for the contraction of a nebula, a gas cloud of molecules to form a protostar. If it's asking about a force, well, then it must be gravity, gravitational force. There's not many other forces that we'll be talking about in earth science, high school leveled earth science. What other forces would there be? Electromagnetic force, force of gravity. Can't really think of any right now. Science teachers, help me out if you can, but usually it's looking for gravity. Here's one more diagram, similar information again. So the diagram represents the inferred stages in the formation of the solar system. Stage 1 shows a contracting gas cloud. So here's our nebula contracting, again, because of gravity. The remaining stages show the gas cloud flattening into a spinning disk, which we see over here, as the planets formed around the sun. So as soon as the process of fusion happens, it becomes into a star, and then gravity is going to keep causing the disk to form into planetesimals and then to planets and asteroids and all of the other objects that we have in our solar system. So here it is. The process was occurring during some of these stages that resulted in the formation of heavier elements from lighter. Well, we know that this is nuclear fusion. So just to wrap it up today, talk about how gravity brought about the formation of the sun in the nebula hypothesis, and then compare it to planetary formation too. So definitely, as you're writing in your answer, of course, talk about the force of gravity, talk about the process of nuclear fusion. Oh my goodness, sorry, I can't type and write. And I would talk about that in relation to both of those things. So does gravity have to do with both of them? Does fusion have to occur with the formation of stars and the formation of planets? Is it happening? The answer is not, because planets don't have the mass and therefore the gravity to cause fusion to happen. So there's a big difference between stars and planets in addition to just the general size. So I hope this video was helpful. Hope it was informative. Definitely take some time to explore the solar system and the surrounding galaxy, and I will see you next time. Have a nice day.